In our applet, we looked at y equals x squared minus 3. This vertically shifted the graph of f of x equals x squared down by 3. But what about the graph of g of x, which is x minus 3 squared? We are still working with the squaring function, f of x equals x squared, but what's different about y equals x squared minus 3 versus our new function g of x, which is x minus 3 squared? With y equals x squared minus 3, we first compute the squaring function, x squared. Then we subtract 3. But with g of x equals x minus 3 squared, we subtract 3 from x first and then square it. A way we can write this is g of x equals f of x minus 3. Because we first subtract 3, that's what's inside the parentheses, and then compute the squaring function. So how does subtracting 3 first affect the graph of f of x equals x squared? To see this, we'll sketch the graph of g of x equals x minus 3 squared point by point. Let's first start with the point x equals 1. Here, g of 1 is 1 minus 3 squared. But 1 minus 3 is negative 2, so we have negative 2 squared, which is 4. So we get the point 1, 4 on our graph. If x is 2, then g of 2 is 2 minus 3 squared, which is negative 1 squared, which is 1. So this means x equals 2, y equals 1 is a point on the graph. Let's include it now. What about if x is 3? Here, g of 3 is 3 minus 3 squared, which is 0 squared, which is 0. So 3, 0 is a point that we can include on our graph. If x is 4, then g of 4 is 4 minus 3, which is 1, squared, which is 1. So we get the point 4, 1. And if x is 5, then g of 5 is 5 minus 3 squared, which is 2 squared, which is 4. So we get the point 5, 4 on the graph. As we pick more and more points, we get a better and better picture of what our graph looks like until we finally have enough points to see the graph. Now that we have the graph of g of x, how does it compare to the graph of f of x equals x squared? Well, the graph of g of x, which is x minus 3 squared, is the graph of f of x equals x squared shifted to the right by 3.